Okay, welcome to ES 300, Environmental Science 300, Energy and the Environment. I'm the instructor, Jordan Kern, and this is the first lecture. And today we're going to talk about motivation for the course, my motivation in teaching it. We'll go through the syllabus, and I'll also talk a little bit about some of the topics that we're going to cover in the course and why. So I want to begin with, in terms of motivation, with sort of a personal anecdote. And this is going to involve a shameless attempt on my part to establish a minimal number of degrees of separation between me and someone famous. And so it involves this guy seated here, Sam Altman. So Sam Altman is somebody who I met a couple times in the past in connection to my alma mater. This is where I went to school. I'm sorry. When I was in high school, I was a pretty good student, and I was applying for a scholarship that UNC offered. It was basically for a free ride at UNC, so very competitive. And as part of that process, they would like bring you to UNC, and you'd have to stay in this hotel and dress up. My parents bought me my first and last suit. And it was, the process in general was pretty awful, but yeah, and you had to interview with people. I met Sam. He was also interviewing at the same time. And he was a really nice guy, unlike a lot of the other, kids there. And I thought, if I, were to come to UNC, he would be somebody I'd be friends with. Um, Anyway, I did not get that scholarship. I went to UNC anyway. Big mistake. He did get the scholarship, did not go to UNC. I showed up on campus as a freshman, and he was nowhere to be seen. And I didn't think twice about it until a couple years ago. And I saw his name in the New York Times or Bloomberg or Wall Street Journal or something like that. And his name seemed familiar. And so I looked him up, and sure enough, it's this guy that I met, 15 years ago. And it turns out he never went to UNC, and he went to Stanford instead. And he was there for a couple years, and then he dropped out. And he dropped out to start a tech incubator. So he was basically in charge of this sort of like common workspace where people would come and develop new ideas in exchange for advice and sort of seed funding. And then he would get, I think, some ownership over some degree of ownership of those ideas that are developed and then commercialized. And he had some big hits, right? So Airbnb, Dropbox, Pinterest, Reddit. And so he's like a billionaire now. So that doesn't matter for our story here. But one of his sort of closer friends is this guy, Elon Musk. And so this has more to do with what we're here to talk about today. So that's my shameless, attempt to connect myself indirectly to Elon Musk. Now that I've done that, one of the things that Sam Altman and Elon Musk have worked a lot together on is sort of an attempt to be watchdogs over the development of artificial intelligence. They're both very concerned that sort of unchecked development of artificial intelligence could lead to real existential risks for humanity in a lot of different forms. I think many of us are probably already familiar with some of Elon Musk's other interests that are sort of in a similar vein, right? Thinking about, and if we sort of pretend, if we're not cynical for a moment, that he's really interested in, I think, advancing the human species and technology that can prolong the longevity and success of the human species. And so he wants to make, for example, humans a multi-planet species. So he's big into colonizing Mars. This is just sort of a conceptual illustration of what his colony on Mars might look like. He certainly a significant proponent of renewable energy generation and vehicle electrification, which could go hand in hand in terms of reducing humans' dependency on fossil fuels. And of course, part of that motivation is thinking ahead about climate change and the very destructive social impacts that could have on people. So this just shows a map of the world, and each one of those red or pink dots represents a city where more than 1 million people live. And what isn't all of these cities have in common is that they're located on coastlines. And so I think, one of the big dangers of climate change, of course, is sea level rise. And as a result of that, the potential for massive displacement of people and physical destruction of property and harm to people's lives. And so the analogy he's using here is that the long-term effects of climate change could be more destructive than all the wars in history combined, and that's quite an image to have in your mind. So one of the things that when you sort of hear Sam Altman and Elon Musk talking about artificial intelligence specifically, but also a lot of these other risks as well, especially climate change, they both have this sort of thinking that we live in a specific sort of window of time, a period of time where we're either going to figure out a lot of the solutions to a lot of our problems, or we're going to head towards on a path that is quite unpleasant. Quality of life will decrease, and the worst case scenario is that civilization or society starts to fall apart. And so that's sort of epitomized in this quote here. So they have this feeling that right now, in the next several decades, are really pivotal in terms of the direction of humanity. Now, that thinking, that idea, is not new at all, and there have been a number of sort of famous examples of that idea being put forward. The idea that we're either going to sort of burn out quickly, or set ourselves up to live as a society, as a species, for a really long time. One of the sort of the origin of that idea is the Drake equation. So this is a mathematical equation that is a probabilistic argument used to estimate the number of active, communicative, extraterrestrial, so alien, civilizations in the Milky Way galaxy. So somebody a long time ago, and we'll get to who, was curious about, let's say we have radio telescopes and we want to try to send signals out into space and communicate with aliens. Could we estimate the number of alien civilizations within our own galaxy, the Milky Way galaxy, that we might be able to reach via radio telescope? And the Drake equation was named after this guy, Frank Drake, who developed it in 1961. And the equation was sort of the main topic of discussion at the world's first meeting on the search for extraterrestrial intelligence, or SETI meeting, that happened in West Virginia. I think we all sort of think about people who spend a lot of time thinking about aliens and communicating with aliens as kind of nuts. But this was a point this was 15 years after World War II. And we're sort of in the at the pinnacle, or close to it, of America and the world's interest in space. And so this was a very serious topic at this point that drew a lot of really significant scientific minds, including Carl Sagan. So Carl Sagan was this famous astrophysicist, astronomer, and a really famous science communicator. So if you ever read the book or watched the movie Cosmos, there's two versions. There's one that Carl Sagan did a long time ago, and there's a new one with Neil deGrasse Tyson. I just, Cosmos is awesome. It's everything that you should have learned in K through 12 science class. Basically, it's a real joy to watch. I highly recommend watching Cosmos. Anyway, Carl Sagan was at this meeting, the first SETI meeting, where the main topic of conversation was the Drake equation. So the Drake equation, there's two sides, right? N is on one side, on the left-hand side, and then there's all this other stuff on the right-hand side. And N is what we want to estimate. N is the number of civilizations in the Milky Way galaxy that we could maybe communicate with using a radio, some sort of radio communication. So if we want to estimate the number of civilizations, aliens, out in the Milky Way galaxy that we could potentially communicate with, we have to think about what would control that number, right? We have to think about, the number of planets that are out there, the number of planets that are circling stars, far enough away, but not too far away where the temperature is adequate for nurturing and hosting life. We have to understand how likely it is that life might develop into intelligent life that could develop radio telescopes and communicate back with us. And so that's what this equation is an attempt to do. All of these different variables on the right-hand side of the equation have different values, right? So the R is the rate of star formation. So how often do new stars form? FP is the fraction of those stars that have planets. NE is the average number of planets that would be going around a star that could support life. So not in the Goldilocks zone, not too far away, not too close. FL is the fraction of those planets that are circling the stars that do develop life. So big question there. Fi is the fraction of that life that then becomes intelligent, even bigger question. FC would be the fraction of intelligent life that develops communication technologies. And then L would be the length of intelligent civilization. So this is important because if we're talking about communicating over huge distances in the Milky Way galaxy, sending sort of a radio signal could take years and years and years and years and years just to get somewhere else, right? So if we're trying to actively communicate with another civilization, if they're too far away from us, we won't actually be able to talk to them. If the average length of a civilization is pretty short. So here are the values that Frank Drake and Carl Sagan and others decided were the most logical fit. And I'll sort of let you go through all of these sort of independently. But I would like to draw your attention to the last one, L. Right, so the what they estimated is the average length of an intelligent civilization that's capable of developing, communication technology is either on the short end 1,000 years or on the long end 100 million years, and that's quite a big range. So if you plug all of those numbers into the equation, it gives you on the minimum end 20. And the big number, right, the maximum range would be 50 million. So given the uncertainties, what they, the range of different values, what they sort of concluded is that sort of when you're talking about orders of magnitude or multiples of 10, that the number of civilizations we could probably talk to is roughly equivalent to L. So the duration of an intelligent civilization that can develop radio telescopes. And so what they suggested is that there were probably between 1,000 and 100 million civilizations in the Milky Way galaxy. And Carl Sagan in particular speculated that except for L, the lifetime of a civilization, all of the terms were probably pretty high, right? He sort of from a logical scientific standpoint. And he thought that L was either really, really small or really, really large, so the length or duration of an intelligent civilization. And I'll bring you back to that quote from Sam Altman and Elon Musk, right? they think that we're in this window of history where we're either going to make choices or develop technologies that help us, go on a path where the duration of or length of human civilization is quite long and sustainable, if you will, or we're on a path where we might sort of self-destruct. Um, and so it was this sort of moment in Carl Sagan's life that started his interest in environmental issues. And I think from a similar standpoint to Elon Musk's. Now, for Carl Sagan, the issues of the day were, nuclear warfare, and he certainly had a less nuanced understanding of climate change and the risks of global climate change for human civilization. But it was a very, very sort of similar idea that they both came upon.